All right, let's talk about one of the biggest, most interesting challenges for web developers today. How in the world do we build user interfaces for the 3D web? I mean, we've spent decades getting really good at putting buttons and text on flat pages. But now, the web is exploding into these amazing, immersive, three-dimensional spaces. And that shift from pages to spaces, well, it changes everything. So let's dive in.
It seems like such a simple question, doesn't it? You've done all the hard work. You've built this incredible 3D scene. It's running smoothly. It looks gorgeous. But at some point, a person has to actually use it. They're going to need menus. They're going to need buttons. They need to see information. So what's the million-dollar question? How do you connect that flat, familiar world of UI we all know and love with the deep, complex world of 3D? Let's walk through the journey of how developers have been tackling this.
Okay, so where do you even begin? Well, the most common starting point, the most direct approach, is to just stick with what you know. This method leans on the bedrock of the web, the technologies every single web developer already uses every day, the document object model, the DOM. And yeah, it is exactly what it sounds like. You literally just stack your normal HTML and CSS interface right on top of your 3D canvas. The real beauty of this is that you get to use all the amazing, super optimized tools the browser gives you, like Flexbox and Grid. There's no need to reinvent the wheel. You're just putting the wheels you already have on a totally different kind of vehicle. And this is where you hit the big trade-off. On the one hand, it's a huge win. It's fast, it uses tech you already know, and super importantly, it's accessible right out of the box for things like screen readers. But there's a big downside. It's totally separate from your 3D world. Your UI is kind of like a sticker on a window. It can look out into the 3D room, but it can never actually be in the room. It can't go behind a 3D object, and it has one massive deal-breaking limitation. And here it is, the hard wall you're gonna hit. The second you try to enter a real immersive VR session, poof, all that beautiful HTML you built just vanishes. It's gone. That's because the browser's normal rendering path gets completely bypassed. So for VR, this whole approach is a complete non-starter. Okay, so if our UI can't really live inside the 3D world, can we at least make the two worlds aware of each other? Can we kind of trick them into working together? That brings us to our next approach, these really clever hybrid methods that use some powerful tools from libraries like Three.js to, well, bridge that gap. The way this works is actually pretty ingenious. You take a totally normal HTML element, like a div or a button, and you wrap it up inside a special Three.js object. Then, when you add that object to your 3D scene, the renderer uses CSS magic to make your HTML element move and scale and even rotate as if it's perfectly locked to a point in 3D space. And you've really got two main flavors here. The CSS 2D renderer is perfect for simple stuff, like labels or tooltips that you always want facing you. Think of a name tag floating over a character in a game. It only cares about position. But then you have its big brother, the CSS 3D renderer. This thing is way more powerful. It can do full 3D rotations and scaling, which means you can build entire interactive panels that feel like they're actual surfaces inside your 3D world. But if you're serious about VR, if you really want that true, deep immersion, you have to do it. You have to leave the DOM behind. It's time to build our interface out of the exact same stuff as our 3D worlds: triangles, pixels, and shaders. Now, this is a huge shift in thinking. Your user interface is no longer a separate layer. It's made of actual objects in your scene. A button? That might just be a flat plane with a picture on it. A menu could be a few of those planes grouped together. And because they are real 3D objects, they get lit properly, they can cast shadows, and, this is key, they can be blocked by other objects, just like anything else in your world. So a classic technique for this is the heads-up display, or HUD, like the health bar in a video game. It's a three-step process. First, you just render your main 3D world as usual. Then you tell the renderer to wipe its depth buffer. That's basically the computer's memory of what's in front of what, but you tell it to keep the picture it just drew. Finally, you just render your simple 2D UI right on top. And because that depth memory is gone, your UI is always guaranteed to show up in front. Okay, but wait, if our buttons are just flat shapes floating in 3D space, how do we actually click on them? The answer is a really cool technique called raycasting. Basically, you imagine shooting an invisible laser pointer from the camera straight through your mouse cursor and out into your scene. The very first 3D object that laser hits, that's the one you've clicked.
It's a simple idea, but it's the foundation for almost all interaction in a native 3D interface. All right, so now we get to the really futuristic stuff. We're moving beyond just putting flat panels into a 3D world and into a whole new way of thinking. This is where, in spatial computing, the environment is the interface. I just love this quote because it nails it. For our entire lives, all software has been trapped inside a rectangle. Your monitor, your phone screen, it's all rectangles. Spatial computing just shatters that box. All of a sudden, we're not designing for a screen anymore. The user's actual physical space becomes our canvas. And that forces us to think less about layouts and way more about, human beings, comfort, interaction, and how our brains work. So what this means is that great spatial design is really less about cool graphics and more about ergonomics. You start asking questions you'd never even think about with a flat screen. Like, is this UI placed in a way that won't give someone next screen? Can you read this text from across the room? Does a menu pop up right next to the thing it controls? The very idea of interaction changes from clicking a mouse to more natural things, like just pointing at something or grabbing it. Now, for any web developer watching, you can probably feel the headache coming on. We are so used to the power of CSS to build layouts. The idea of manually placing every single button using X, Y, and Z coordinates, it's a total nightmare. But here's the good news. This is where modern frameworks are a total game changer. Libraries like PMDRS/UKit have literally re-implemented web tools like the Flexbox engine to work inside of WebGL. So you get to use those familiar concepts to arrange your 3D UI, giving you the best of both worlds. Wow. Okay, so we have covered a lot of ground here, haven't we? We've gone from what are basically just stickers on a screen all the way to designing entire interfaces that we can literally walk around in. Let's just quickly recap this incredible journey. You can really see the evolution here. We started with the easiest path for the 2D web, just using HTML overlays. Then we got a little more clever for the hybrid web, using those CSS renderers to make our UI feel like it's part of the scene. For true immersion, for VR, we had to go fully native with WebGL. And that brings us right to today, the dawn of the spatial web, where we design interfaces not for screens, but for people. So I want to leave you with this one last thought. If our job is slowly changing from arranging rectangles on a flat page to designing comfortable, intuitive, useful spaces for people to exist in, does that mean we're all becoming architects? The line between web developer and architect is getting really blurry, and honestly, it is an incredibly exciting place to be. Thanks for tuning in.